Hey everyone. So welcome to this first video in this short course where we're going to build and train a neural network to classify or sort emails. Now the idea here is to give you an understanding of classification problems for neural networks. And we're going to choose the problem of classifying emails as our example. So let's do a quick overview of what a classification problem is. Now a classification problem, as the name suggests, is very simple, right? What it does is given an input and a machine learning model, in our case, we're looking at a neural network. The job of the model is to just predict what class the input belongs to. So, does the input belong to class 1, class 2, or class 3? And as you can see here, the input is basically a vector, right? Which is basically a collection of numbers that represents the quantity it's trying to classify. So, for example, you could have an image classification problem where you have an image like this, and the problem of the neural network or the machine learning model is to try and figure out whether the image is that of a cat or a dog or say a lion. And so image classification problems are a very big a problem set, um, that a lot of deep learning models try and solve. There's also the exceptionally widely used now problem of network predictions, which is what large language models are all about. So, given the first two words, how are the model, NLP model, large language model, is trying to predict what the next set of words or next token is. In this case, it's is it how are me, how are I, or how are you, right? And the model has to predict that. So it's another classification problem right there. Then, of course, we have the question of sentiment analysis. So, for example, you have a review of a product, let's say, and you know the goal is to try and figure out whether the review is positive or negative, right? Again, it's trying to classify the review. And then of course in our case we have email classification, which is what I've chosen for this series. Now it could just be as simple as a spam filter, right? And so that's a binary classification problem. So you have two classes, um, and it's either spam or not spam, but we're going to do something slightly more interesting where we're going to actually have a number of different classes, and we've created a data set for this. And the goal is to pick, or rather train the algorithm to pick which class the email or message belongs to. So what's the data set we're looking at now? And even though I'm saying email, and that's what you can use the network eventually to train it for, we're going to keep the emails very simple. It's almost going to be almost like the subject of the email, right? Because we want to keep the data set simple enough that we can actually train it as part of this course. So, for example, the spam would be a message like this that says win a free iPhone 14 by clicking on this link, right? Typical spam messages that you're probably used to seeing. Could have a social media message, which is, for example, something telling you that you have a friend request. You could have a work message, so something about an important deadline. Have something from marketing from some app you're subscribed to, right? So something about subscription, let's say. Then we have a class called important, which is about something time critical, let's say. And of course, personal message, right? So it's not spam, it's somebody wishing you, in this case, for your birthday. So these are some examples of those messages of the different classes. And when we kind of get to the point where we're actually training the network, we'll have the data set, and I'll post the GitHub link for the code and the data set so you can check the data set out. And we've created this data set specifically for this course. So you can go ahead and then at the end of the course, hopefully use this and train it on, maybe emails that you get and see if it works, right? Now, the first step that we'd have to do, and I'll overview the different steps you're going to be covering as part of this course in this video. The first thing we're going to have to do for a neural network to be able to classify the text is convert the text into a vector, right? Because the neural network is only going to understand numbers. So we're going to use an embedding model. In this case, we're going to use sentence BERT. And so we'll do a quick overview of that as we go through the series. And the sentence BERT will take this text, for example, in this case, get rich quickly with a guaranteed money making scheme. It's going to take that text and convert it into a vector, which is what the neural network is going to train on. And so if we take those vectors, reduce them into a two-dimensional form using, in this case, principal component analysis, which means we can visualize our messages. And I'm showing you an example of the subset of the messages. You see how the message distribution is. So in some cases, you have, for example, personal messages, which are all clustering here. You have work, which is clustering here. But you also have some that are all over the place. So important, for example, is all over the place, right? It's it could also be work. Some of it is showing up in social media. You're seeing that spam and social media are overlapping, and then you have the marketing emails again, which is overlapping in some cases with spam. So it's an interesting data set. We've tried to mix it up a bit, and then we'll see how well neural network does to try and classify this. So the first piece that we'll have to cover, and we'll do a review of this over the next few videos, is the neural network, right? Which is basically a collection of neurons. So the input would go into the network, which means the input layer of that neural network, which is in this case the first layer, will have the same number of neurons as the size of this vector. And then we'll have the hidden layers, and we're going to be using tanh neurons. So we'll kind of do a quick overview of that in one of the next videos. But the inputs will be fed into those layers, which will process the input. And then you'll have the last layer. So the layer here, last hidden layer in this case, will have the same number of outputs as the number of classes, which is 6 in our case. But this will just give us a set of numbers. What we want now is to classify. And so what we're going to use, and what we'll kind of go through in a lot of detail, is the softmax layer, or the softmax function, right? Which is this function, right? Which is going to take in the inputs from the last layer, or the second last layer, I guess, in this case, and then convert it. Effectively, what it does is convert it into a set of probabilities, right? And so we'll kind of really go into a little detail of how the softmax function works, because it forms the foundation or the basis of classification problems, especially for neural networks. And then once we have the network, we now need a way to train it, right? So what we're going to explore then is the NN cross-entropy loss, because given a prediction, and in this case, I've just given 3 outputs, for example, so assume they're just 3 classes. You have an actual label, and we've used the one-hot encoding here, so we'll explain that as well. But you see that this is the actual class. You now need a way to compare this and tell the neural network how accurate it is, right? And so the typical approach to do that is the NN cross-entropy loss, which is given by this formula. And we'll explain this in quite a bit of detail again, go over the derivation and the math so that you understand it in detail, and we'll implement this as well. Once we've done that, we'll then train the network, right, using a gradient descent algorithm. And we've covered gradient descent in quite a bit of detail in the series on deep learning from scratch. So I'll add a link to that. And in case you're, you need to kind of refresh that, you can go check out those videos. So what we'll be implementing through this series is basically taking the data and, passing it through an embedding model. We won't implement the embedding model. We'll use, the sentence transformer model, but you'll see how to do that. We'll then kind of build the neurons and then build the network. And we're going to build that from scratch. We're not going to use PyTorch or TensorFlow or anything like that. Again, the idea is to give you a review and a feel for how these neural networks work. And then we'll kind of implement the softmax. We'll explain it and implement it. And then the NN cross entropy, and then we'll train. So by the end of it, you'll understand how each of these pieces works in quite a bit of detail. And you will then be able to take this understanding and apply it to, hopefully, to other classification problems. So by the end of this set of videos, these are the topics that you will have a fairly good understanding of. So hopefully this has now whetted your appetite and you're ready for the next set of videos where we'll go through these pieces in quite a bit of detail. So see you in the next one.